Hi all, this is Tamarai back to you all. In this video, we are going to learn a complete tutorial on Hadoop. Let's get into the video. Hadoop is an open source framework that allows to store and process big data in a distributed environment across clusters of computers using simple programming models. It is designed to scale up from single servers to thousands of machines, each offering local computation and storage. This brief tutorial provides a quick introduction to big data, MapReduce algorithm, and Hadoop distributed file system. Hadoop is an open source framework based on Java programming. It is not a methodology or anything else. It manages the storage and processing of large amounts of data in an application. Hadoop uses distributed storage and parallel processing, breaks workloads into smaller workloads that can be run at the same time. It is a well-known big data processing system for storing and analyzing enormous volumes of data. It's an open source project that you can use for free. If you are new to Hadoop, you may find the installation process little difficult. I will walk you through the steps of installation Hadoop on Windows. Step 1. Download and install Java. Hadoop is built on Java, so you must have Java installed on your PC. You can get the most recent version of Java from the official website. After downloading, follow the installation wizard to install Java on your system. Step 2. Download Hadoop. Hadoop can be downloaded from the Apache Hadoop website. Make sure to have the latest stable version of Hadoop. Once downloaded, extract the contents to a convenient location. Step 3. Set environment variables. You must configure environment variables after downloading and unpacking Hadoop. Launch the Start menu, type Edit the System Environment Variables, and select the result. This will launch the System Properties dialog box. Click on the Environment Variable button to open. Click New under System Variable to add a new variable. Enter the variable name and the path to the Hadoop folder as the variable value. Then press OK. Also change the environment variable window and enter. To close all the windows, use the OK button. Step 4. Set Hadoop. You must configure Hadoop in this phase by modifying several configuration files. Navigate to the etc Hadoop folder in the Hadoop folder. You must make changes to 3 files: core site.xml, hdfs site.xml, mapreduce.xml. This is the core site.xml file. The tags containing values, names, and properties inside configuration tag must be changed. This is mapreduce.xml file. Here, the name tag, value tag, property tag, inside configuration tag should be edited. The MapReduce is an algorithm that is used in Yarn framework. We will discuss this later. Yarn manages map and reduce functions of MapReduce algorithm. Here we have two tags to change map function and reduce function inside configuration tag. HDFS. It is an distributed file storage platform which contains name node and data node. They are specified in different tags under configuration tag. And finally, Hadoop env file is edited. The set path is edited in this file. Step 5. Format Hadoop name node. You must format the name node before you can start Hadoop. Navigate to the Hadoop bin folder using a command prompt. Execute the command given below. Step 6. Start Hadoop. To start Hadoop, open a command prompt and navigate to the Hadoop bin folder. Run the following command given below. Step 7. Verify Hadoop installation. To ensure that Hadoop is properly installed, open a web browser and go to the command. This will launch the web interface for the Hadoop name node. You should see a page with Hadoop cluster information. Here is an overview about big data. 90% of the world's data was generated in the last few years. What is big data? Big data is a collection of large data sets that cannot be processed using traditional computing techniques. It is not a single technique or a tool. Rather, it has become a complete subject, which involves various tools, techniques, and frameworks. Big data comprises of five major V's, but the upcoming data has given 10 V's of big data: visualization, velocity, variety, variability, volume, vulnerability, validity, volatility, veracity, value, or the 10 V's. What comes under big data? Big data comprises all types of data: structured data, semi-structured data, and unstructured data. Structured data like relational data, SQL table data. Semi-structured data is the data of email. Unstructured data, Word, PDF, text, audio file, video file, and media logs. It also involves the data produced by different devices and applications. Given below are some of the fields: black box data, social media data, stock exchange data, power grid data, transport data, and search engine data. Big data technologies are important in providing more accurate analysis, which may lead to more concrete decision making, resulting in great operational efficiencies, cost reduction, and reduced risk for the business. To harness the power of big data, you would require an infrastructure that can manage and process huge volume of structured and unstructured data in a real time and can protect data privacy and security. There are various technologies in market from different vendors including Amazon, IBM, Microsoft, etc. to handle big data. While looking into technologies that handle big data, we examine the following two classes of technologies: operational big data and analytical big data. Operational big data. This includes systems like MongoDB that provides operational capabilities for real-time, interactive workloads where data is primarily captured and stored. NoSQL big data systems are designed to take advantage of new cloud computing architectures that have emerged over the past decades to allow massive computation to be run inexpensively and effectively. This makes operational big data workloads much easier to manage, cheaper, and faster to implement. Analytical big data. These include systems like massively parallel processing, called MPP, database system, and MapReduce. They provide analytical capabilities for restoring and complex analysis that may touch most or all of the data. MapReduce provides a new method of analyzing data that is complementary to the capabilities provided by SQL and a system based on MapReduce that can be scaled up from single servers to thousands of high and low end machines. These two classes of technologies are complementary and frequently developed together. As big data covers many advantages: timely decisions, audience knowledge and loyalty building, immediate results of feedback, differentiate technologies and market with futures, high storage and capacities. This also includes some challenges. The major challenges associated with big data are capturing data, storage, searching, sharing, transferring, analysis, preservation, and security concerns. Let's see big data solution. The first one is traditional approach. In this approach, an enterprise will have a computer to store and process big data. For storage purpose, the programmers will have to take the help of their choice of data vendors such as Oracle, IBM, and so many. In this approach, the user interacts with the application, which in turn handles the part of data storage and analysis. Also has some of the limitations. This approach works fine with those applications that process level and less voluminous data that can be accommodated by standard database servers or up to the limit of the processor that is processing the data. But when it comes to dealing with huge amounts of scalable data, it is a hectic task to process such data through a single database and creates a bottleneck effect. Here comes the Google solution. Google solved this problem using an algorithm called MapReduce. This algorithm divides the task into small parts and assigns them to many computers and collect the results from them which when integrated from the result dataset. Here is an commodity hardware which gets the data from centralized system and the data are mapped and reduced. Hadoop. Using the solution provided by Google, Dogo Cutting and this team developed an open source project called Hadoop. Hadoop runs applications using the MapReduce algorithm, where the data is processed in parallel with others. In short, Hadoop is used to develop applications that could perform complete statistical analysis on huge amount of data. Introduction to Hadoop. Hadoop is an Apache open source framework written in Java that allows distributed processing of large datasets across clusters of computers using simple programming models. The Hadoop framework application works in an environment that provides distributed storage and computation across clusters of computers. Hadoop is designed to scale up from single server to thousands of machines, each offering local computation and storage. Hadoop architecture. At its core, Hadoop has two major layers, namely processing layer and storage layer. Processing layer contains MapReduce algorithm and storage layers contains Hadoop distributed file system that is called as HDFS. The architecture also comprises MapReduce, HDFS, Yarn, and Hadoop Common. MapReduce. MapReduce is a parallel programming model for writing distributed application devised at Google for efficient programming and processing of large amount of data, multi-terabyte data sets. On large clusters, thousands of nodes of commodity hardware is in reliable, fault-tolerant manner. The MapReduce program runs on Hadoop, which is an Apache open source framework. HDFS, Hadoop Distributed File System, is based on the Google file system and provides a distributed file system that is designed to run on common and commodity hardware. It has many similarities with existing distributed file systems. However, the difference from other distributed file systems are significant. It is highly fault tolerant and it is designed to develop on low-cost hardware. It provides high throughput access to application data and is suitable for applications having large data types and data sets. Apart from the above mentioned two core components, Hadoop framework also includes the following two modules, Hadoop Common and Hadoop Yarn. Hadoop Common. These are Java libraries and utilities required by other Hadoop models. Hadoop Yarn. It is a framework of job, scheduling, and clustering resources management. Are you interested to learn how Hadoop works? Let's see. It's a quite expensive to build bigger servers with heavy configurations that handle large-scale processing, but as an alternative, you can tie together many commodity computers with single CPU as a single functional distributed system, and practically the clustered machines can read the dataset in parallel and provide a much higher throughput. Moreover, it is cheaper than one high-end server. So, this is the first motivational factor behind using Hadoop, that it runs across clustered and low-cost machines. Hadoop run code across a cluster of computers. This process includes the following code tasks that Hadoop performs. The data are initially divided, the files are then distributed, HDFS being on the top of the local file, blocks are replicated, and checking the code was executed successfully, performing the sort for MapReduce task, sending the sorted data, writing the debugging logs for each job. There are so many advantages of using Hadoop. Here are few listed. Cost, scalability, flexibility, speed, fault tolerance, high throughput, minimum network traffic. HDFS, Hadoop Distributed File System, is utilized for storage permissions, and processing. It is mainly designed for working on commodity hardware devices, inexpensive devices, working on a distributed file system design. HDFS is designed in such a way that it believes more in storing the data in large chunks of blocks rather than storing small data blocks. HDFS is a Hadoop provided fault tolerant and high availability to the storage layer and the other devices present in the Hadoop cluster. Data storage nodes in HDFS are name node, also called as master node, data node, also called as slave node. Name node. The name node works as a master in a Hadoop cluster that guides the data nodes called a slave node. Name node is mainly used for storing the metadata. The data about the data is called metadata. Metadata can be transcriptioned into logs that keep track of the user's activities in a Hadoop cluster. Metadata can also be the name of the file size, and the information about the location, like block number, block IDs of data node that name node stores to find the closest data for fast transfer commission and communication. Name node instructs the data node with the operations like delete, create, replicate, and so many. Data node. Data node works as a slave. Data nodes are mainly utilized for storing the data in a Hadoop cluster. The number of data nodes can be from 1 to 500 or even more than that. The more number of data nodes the Hadoop cluster will be able to store more data. So it is advised that the data node should have high storing capacity to store a large number of file blocks. High-level architecture of Hadoop contains file blocks in Hadoops. Data in Hadoops is always stored in terms of blocks so that the single block of data is divided into multiple blocks of size 128 MB, which is default, and you can also change it manually. Let's understand the concept of breaking down a file into blocks with an example. Suppose you have uploaded a file of 400 MB that your HDFS, then what happens? It is then the file got divided into blocks of 128 MB plus 128 MB plus 128 MB plus 16 MB equal to 400 MB size. Means 4 blocks are created each of 128 MB except the last one. Hadoop does not know or it doesn't care about what data is stored in these blocks. So it is considered that final file block as a partial record as it does not have any idea regarding it. In Linux file system, the size of a file block is about 4 KB, which is very much less than the default size of the file block in Hadoop file system. As we all know, Hadoop is mainly configured for storing the large size data, which is in petabyte. This is what makes Hadoop file system different from other file systems as it can be scaled. Nowadays, file blocks of 128 MB to 256 MB are considered in Hadoop. The main concept is replication in Hadoop. Replication ensures the availability of the data. Replication is making a copy of something, and the number of times you make a copy of that particular thing can be expressed as a replication factor. As we have seen in file blocks that HDFS stores the data in the form of various blocks. At the same time, Hadoop is also configured to make a copy of those file blocks. By default, the replication factor of Hadoop is set to be 3, which can be configured, means you can change it manually as per your requirement like above example. We have made 4 file blocks, which means the recipient or copy of replication file blocks is made means totally of 4 into 3 is equal to 12 blocks are made for the backup process. This is because for running Hadoop, we are using commodity hardware, inexpensive system hardware which can be crashed at any time. We are not using the supercomputer for a Hadoop system setup. That is why we need such a feature in HDFS which can make copies of that file blocks for backup purposes. This is known as fault tolerant. Now, one thing we also need to notice that after making so many replicas of your file blocks, we are wasting so much of the storage. But for the big brand organizations, the data is very much important than the storage of nobody can exist the extra storage. You can configure the replication factor in your HDFS site by using the code hdfs-site.xml file. Rack awareness. The rack is nothing but just the physical collection of nodes in a Hadoop cluster, maybe 30 to 40. A large Hadoop cluster is consists of so many racks. With the help of racks, information name node chooses the closest data node to achieve the maximum performance while performing the read and write operation information, which reduces the network traffic. The main concepts are HDFS holds very large amount of data and provides easier access, fault detection and recovery, huge datasets, hardware and data are the main basic components of HDFS. Hadoop operation modes. Once you have downloaded Hadoop, you can operate your Hadoop cluster in one of the three supported modes: local or standalone mode, pseudo distributed mode, fully distributed mode. Local or standalone mode. After downloading Hadoop in your system, by default, it is configured in a standalone mode and can be run as a single Java process. Pseudocode or distributed mode. It is a distributed simulation on a single machine. Each Hadoop daemon such as HDFS, Yarn, MapReduce, etc. will run as separate Java process. This mode is useful for development and deployment. Fully distributed mode. This mode is fully distributed with minimum 2 or more machines as a cluster. We will come across this model in detail in this coming chapter. Starting to shutting down of HDFS Hadoop. Starting HDFS. Initially, you have to format the configured HDFS file system. Open name node HDFS server and execute the following command. After formatting the HDFS, start the distributed file system. The following command will start the name node as well as the data node as cluster. Listing files in HDFS. After loading the information in the server, we can find the list of files in a directory. Status of a file using ls. Given below is a syntax of ls, that you can pass the directory or a file name as an argument. Inserting data into HDFS. Assume we have data in the field of file called file.txt in the local system, which is out though to be saved in the HDFS file system. Follow the steps given below to insert the required file in the Hadoop file system. Step 1. You have to create an input directory. Step 2. Transfer and store a data file from local system to a Hadoop file system using the command. Step 3. You can verify the file using ls command. Rectifying data from HDFS. Assume we have a file in HDFS called outfile. Given below is a simple demonstration for retrieving the required file from Hadoop file system. Step 1 here is the initially view the data from HDFS using cat command. Step 2. Give the file from HDFS to the local file system using get command. Shutting down the HDFS file. You can shut down the HDFS by using the command stop DFS. MapReduce, nothing but just like an algorithm or a data structure that is based on the Yarn framework. The major feature of MapReduce is to perform the distributed processing in parallel in a Hadoop cluster, which makes Hadoop working so fast. When you are dealing with big data, serial processing is no more of any use. MapReduce have mainly two tasks which are divided phase-wise. In first phase, map is utilized and in next phase reduce is utilized. Here we can see the input is provided to the map function, then its output is used as an input to the reduce function, and after that we receive an output finally. Let's understand what the map and reduce function does. As we can see, the input is provided to map function. Now, as we are using big data, the input is set of data. The map function here breaks the data blocks into tuples that are nothing but a key value pair. These key value pair are now sent as an input to reduce function. The reduce function then combines this broken tuple or key value pairs based on its key value and form a set of tuple and perform some operations like sorting, summation type, job, etc., which is then sent to the final output node. Finally, the output is obtained. The data processing is always done in reducer depending upon the business requirement of the industry. This is how first map function and the reduce is utilized one by one. Let's understand the map task and reduce task in detail. Map task. Recorder reader. The purpose of recorder reader is to break the records. It is responsible for providing key value pair in a map function. The key is actually its location information and value is the data associated within it. Map. A map is nothing but a user-defined function whose work is to process the tuple obtained from the record reader. The map function either does not generate any key value pair or generate multiple pairs of these tuple. Combiner. Combiner used for grouping the data in the map workflow. It is similar to a local reducer. This intermediate key value that are generated in map is combined with the help of the combiner. Using combiner is not necessary as it is optional. Partitionary. Partitioner is responsible for fetching key value pairs generated in the mapper phase. The partitionary generates the shard and shard corresponding to each residuous reduces. Hand codes and hash codes of each key is also fetched by this partition. Then partitioner performs its hash codes modules with the number of reduces. Reduce task. Shuffle and sort. The task of reducer starts with this step. The process in which the mapper generates the intermediate key value and transfers them to the reducer task is known as shuffling. Using the shuffling process, the system can sort the data using its key value. Once some of the mapping tasks are done shuffling, being that is why it is a faster process and does not wait for the completion of the task performed by the mapper. Reduce. The main function or task of the reduce is to gather the tuple generated from map and then perform some sorting and aggregation sort of process on the key value depending on its key element. Output format. Once all the properties are performed, the key value pairs are written into the file with the help of record writer, and each record is new line and the key value is space separated manner. This chapter explains the setup of the Hadoop multi-node cluster on a distributed environment. As the whole cluster cannot be demonstrated, we are explaining the Hadoop cluster environment using three systems, one master and two slaves. This also follows the same file changes, but it contains two slave nodes and two configurations. A multi-node cluster in Hadoop contains two or more data nodes in a distributed Hadoop environment. This is practically used in organizations to store and analyze their petabytes and exabytes of data. Learning to set up a multi-node cluster gears you closer to your much-needed Hadoop certification. They plays the main role of task tracker, job tracker in map and reduce functions. Here is the end to this tutorial. Let me know in the comments if you found this post useful and follow me as I go on my content journey. Happy Hadooping! Thank you.